to write our own functions in C. Watch the video till the end for a quick demonstration on the 4 types of functions and the important concept of recursion with examples. What is a user-defined function? It's a block of code written by the programmer which is given a name and which can be invoked any number of times. This block of code is executed only when it is called. The function may return a value or it can be void. What is the need for user-defined function? It allows code reusability, so you could write a block of code once and use it or invoke it any number of times. And it supports modular programming. Instead of writing an entire program as one whole code, we can break them as user-defined functions, and it helps in understanding the logic, and it also helps in debugging in case there is an error. The components of a user-defined function can be broadly listed as these: the prototype or the declaration. Just like we declare variables before use in C, we have to declare a function before use, and that's called a prototype. Then the function definition, which is comprised of the function header and the function body, and ultimately is a function call. Only when the function is being called, the function body is going to be executed. The basic syntax of a user-defined function: we have a return data type followed by the function name, which will follow all the rules of naming an identifier or a variable, and then within parentheses the list of arguments, and following that we have a block, the curly brackets, and that will contain the statements which will comprise the function body, and finally we'll have a return statement. Like we just saw, the return statement is optional. So if the function is not returning a value, there need not be a return statement, in which case the return type will be treated as void. So a void is in case the function does not return a value. When I represent the return type to be int, float or a char, it means the function returns a value, and the return type which you mention here and the value that's been returned using the return statement must match. The 4 types of user-defined functions based on the arguments it takes and the return value have been listed here. We shall see examples for each one of this to understand better. Recursion refers to a function calling itself, and for this to happen, in the function body there has to be a base condition which will ultimately terminate the function from being called over and over again. If you miss the base condition, then the function will keep calling itself repeatedly, and there will be a memory overflow and the system will crash. And for this concept of recursion, we make use of the stack memory of the system. Let's look at the first type of the function, user-defined function that does not take anything and does not return anything. Now let's have a header where the function does not return anything. I shall mention the return type to be void. I'll call my function as disp, and the function does not take any arguments. So I have the argument list left empty. So following the function header, I have put a block, and within the block my function body is just to have one message: welcome to UDFs. So that is my function body. So this whole thing now represents the function definition. Now in the main, the function is going to be called, and when the function does not return any value, it's enough to have a function call like that, just mentioning the name of the function. And since the function does not take any arguments, we could leave the function call just like that. So when I run the code, we know execution starts from the main. Now within the main, the first statement is a function call. So when the compiler encounters a function call, it transfers the control to the part where the definition of the function is stored in memory. The body of the function is executed, and then the control is transferred back to the statement after the function call. So internally this is the operation that happens. This is one way to have the definition written. Now if you notice, I have written the definition of the function above my main. So this is treated as a global definition. Now in case I have the definition following the main like this, now when I execute the code, this is going to throw an error, because at the point where the function call is encountered, the compiler is not aware of what disp is. So in such a case, this definition which is following the main is not going to be invoked. Now to overcome this error, we can have a prototype or a declaration to notify the compiler that this function call corresponds to a definition which is coming up later. So a prototype we just saw, the syntax is going to be the return type, the name of the function, and then the argument list. This is a declaration, so we terminate that with a semicolon. So once you have declared the function, it's okay to have the definition following the main, and now when you execute there won't be an error. So the thing is, the function has to be defined before the function call is encountered. If that is not the case, then you must have had a prototype to notify the compiler what this function call corresponds to. Now when the prototype is put above my main, that is called a global prototype, and the advantage of having a global prototype is that any other UDF which is one another user defined function that is defined also can invoke the function which has been declared globally. Now how else can you have a prototype? I can have the prototype locally. So if this statement was going to be enclosed within the main, then this is called a local prototype, and the meaning of a local prototype is that this function that has been declared can be invoked or can be called only within the main. Suppose if you want your function definition to be invoked within either the main or other user defined functions also, then the best thing will be to have a prototype that is mentioned globally. Let's now look at the second function type, the function that does not return a value. So I have a void and which takes some values. It takes arguments. So my function is called add, and I'm passing two variables a and b. Now in the function header, the variables that I mentioned, they are called formal parameters, and they are local to the function definition. The a and b are accessible only within the function definition, they are not accessible outside. Now in my main, for passing values to these formal parameters, I shall declare two variables, and either we can read the values at runtime or we can statically initialize values while writing the code. So just now I have statically initialized x and y to 10 and 14 respectively. Now when a function does not return a value, it's enough to have a call which is just the function name, and since the function takes parameters, I'm going to pass the argument list like this. So in the function call, the variables that I pass are called actual arguments, which are copied onto the variables that are mentioned in the function header, that is your formal parameters. And the statement within the body, I'm going to add up these two formal parameters and show the result within the definition itself as a plus b. Since the result is being printed within the definition, I'm not going to return any value back to the main. So a function that does not return value but takes two arguments. So when I run the code, the sum of 10 and 14 has been shown as 24. Now the third type of the function, where the function returns a value but does not take any arguments. So assume I have two global variables. So global is anything that appears above my main, and what is the feature of global? It is accessible within any function, within the main function or the user defined function and so on. So I have two global variables a and b. So since they are global, it is accessible within my definition as well. So I'm going to return the sum of a and b. So the global variables are accessed within the function body, they are being summed, and the summed value is being returned. So back in the main, anytime a function returns a value, the function call, there are different ways of writing a function call. Either you can have a variable, LHS variable, which will take the return value of the function, and then you can go on to display that return value with the appropriate prompt like that, or you could have clubbed the function call within the printf also. So this clubbing of a function call within the printf is possible when your user defined function returns a value. So if and only if the function returns a value, that call can be clubbed within a printf. So let's execute. So the first statement is the result of the variable result, and the second statement is the display from the function call, which is directly included in the printf. So when a function returns a value, you can use the function call on the RHS and have a variable assigned on the LHS, or you can club the function call within the printf, or you can make use of the function call within a statement, a condition. So if add returns a even number, so something like that. The function call can be part of a conditional statement, and all these are possible when functions return values. Now the fourth type of function, where the function takes arguments and returns a value. So the two formal parameters of function takes are a and b, and what is my function body supposed to do? Return the summation of a and b. So this value which is being summed is returned back to the main. Therefore the display of the result must happen in the main. So like before, as I explained, when a function returns a value, you can either have the function call on the RHS assigned to a variable on the LHS, or you can club the function call in the print. So I might want to say sum of the x value and the y value is equal to, so I have format specifiers mentioned accordingly. So first format specifier I'll mention a x, the second I'll mention a y, and for the third, that is this format specifier, I shall mention the function call passing the actual arguments x and y. So when I execute the code, the result has been obtained here. So the four types of functions have been explained with examples. The most common example used for explaining recursion is factorial of a given number. We know factorial of any number is all numbers multiplied from starting from 1 until the given number itself. The product of all those numbers is going to be the result of the given number. So let's say the actual argument x has been assigned to a 5, and like before I have included the function call in the printf. So when the function call is encountered, the control is transferred to this part of the memory which contains the definition, and in my definition, like we saw in the slide, we have to have a base condition which will terminate the function from calling itself thereafter. So the base condition has to be properly written. Let's say when a has reached a 1, then I shall return 1 itself. Otherwise you return every value of a multiplied by the function calling itself, this time with the a minus 1. So try and visualize this. So I'm calling fact with a 5. So the first time a is equal to 5 is not true, therefore this part of the statement will be executed. So what is the effect here? A's value 5 is multiplied with fact of 4. So when you have a function call as part of the return statement, the control will not be returned yet because it's a function call that's happening. So this value is stored in the stack memory, and the function call is being attended to. So this particular function call, when it goes back and checks a, which is a 4, is not equal to 1, so this function call will return a 4 into fact of 3. So again, when the function calls itself, 3 equals 1 is not true, so this particular function call would have resulted in a 3 into fact of 2. Same way, this function call would have resulted in a 2 into fact of 1, and when 1 is finally taken by a equals 1 is true, therefore 1 is being returned. So the 1 that is returned is substituted at that point, and since there are no more function calls, the previous values which are stored in the stack memory will be manipulated, and the result 120 will be returned back to the main, which is going to be printed here. So when I run the code, I get factorial of 5 to be a 120. Another interesting example to understand recursion: to sum two numbers, adding two numbers we saw with a normal UDF. This time we'll see using recursion. So basically I have a x and y assigned to 5 and 3 respectively. So what is 5 plus 3? let's say we can have this explained as 5 added with 1 3 times. So x plus y is x added with y number of ones. So having this logic in mind, my base condition I'm going to write as, if b has become a 0, at that point it has to return a. Otherwise the function has to return 1 plus sum of a comma b minus 1. So let's understand this logic here. So for the first time, when 5 plus 3 is being passed, a takes a 5, b takes a 3. So 3 equals 0 is not true. Therefore this return would have been executed. So that's a 1 plus, I'll call the function again, this time with a 5 comma 2. Now when the control goes back here, b taking a 2, 2 equal to 0 is not true. Therefore this particular function call would have returned a 1 plus a sum of 5 comma 1. So again the b taking a 1, 1 equal to 0 is not true. Therefore this particular function call would have resulted in a 1 plus sum of 5 comma 0. So at this point b has become a 0. Therefore the if statement would have been executed, where the a's value is being returned. So this particular function call would have returned a which is a 5, and thereafter the rest of the values which are stored in memory are computed, and the result 8 is going to be returned, which will be displayed back in the main. So let's execute this and see. Sum of 5 and 3 has been displayed to be a 8. So very interesting example to understand recursion. The important concept about UDF is pass by value and pass by reference, the two ways by which the actual arguments and formal parameters work. So this is a typical example to explain pass by value. I have a user defined function which takes a formal argument parameter a, and within the definition I'm incrementing a's value with a 5, and in the main the actual argument x is passed, which has got an initial value 5. But when I run the code, within the definition the function value would have a's value would have changed to a 10, but back in the main a continues to be a 5. So in case of pass by value, a copy of the actual argument is made to the formal parameter. So changes made to the formal parameter will not reflect in the actual argument. So how to overcome this? So the other pass method is pass by reference, where we make use of pointers. Though we haven't seen pointers yet, pointers we know basically takes the address of a memory location. So the address of the variable x is passed, which is taken by the pointer a. The content of a is incremented with a 5, and now the changes made to the formal parameter will be reflected in the actual argument, like as shown here. That's because both x and the pointer a, which is pointing to x, are working with the same memory location. So when you want changes made to the formal parameter to be reflected in the actual argument, we work using the pass by reference concept, where pointers are being made use of. More codes on UDFs have been discussed along with its solutions, and the program listing has been shown here. The solutions for all these are available in my GitHub repository, whose link is as shown here, and it's also mentioned in the description. Coming up next, we'll learn pointers in C. Do subscribe for more videos in C. Happy coding!